In this video, we'll start going over Newton's first and Newton's second law. In this video, you will firstly learn the formulas and equation for these laws, as well as you will learn how to draw a free body diagram, a sketch that we will need to draw for every single problem in this unit. So we will learn all the types of forces, their directions, and the situations when they're applied. So if you're confused on how to do free body diagrams, this would be a perfect place to start. Let's start by examining Newton's first law of inertia. So all it's saying is that a body at rest remains at rest and a body in motion stays in motion unless it is acted upon by a force. This is often also called a law of inertia because inertia is a tendency for an object in motion to stay in motion or for an object at rest to stay at rest. But what does this law really mean? All that it means is that in order to make an object stop, you need to apply a force, and in order to make the object move, you need to apply a force. So you just really need to understand this conceptually. There's no equations linked to it, and maybe you will have just a few multiple choice questions on it, but it's not as important as the Newton's second law because it has an equation that links the net force, which is the sum of all forces that are applied on the objects. By the way, the forces we measured in the units of newtons, times mass times acceleration. So mass is in units of kilograms and acceleration is in units of meters per second squared. So the most confusing part is probably this F of net, right? This net force. What is the net force? So net force is just the sum of all the forces applied to the object. So let's say if I'm pushing on the object with a force of 5 newtons and then with a force of 10 newtons, my F net is going to be the sum of these two. So 5 plus 10 or 15 newtons, right? So the other thing to keep in mind is that the link, this equation is also the link between this unit, which is the unit that has to do with forces called dynamics, and kinematics, a unit that has to do with velocity, acceleration, and time. Now, let's take a look about what types of forces exist there, because the most important part of this unit is knowing how to draw a free body diagram, which is a sketch of forces that are applied on the objects. So in order to draw the sketch, right, you need to know two things. You need to know what would be a direction of any given force, and you also need to understand, does that force even apply in that situation or not? So let's start with applied force. Applied force is simply a force applied by a human, a crane, or an object, right? So in the problem, it would say something like this. A human, or let's say it's pushing on a box with a force of 5 newtons, right? So that would be an example of applied force. In other words, the situation is, it would be said directly in the problem, right? If there is any external force applied on the object. And the direction is, well, depending on the direction of the application. If the problem says that I'm pushing on the object to the right, then the applied force is to the right. If the problem says that it's up, etc. Notice, by the way, I'm going to draw all these forces from the center because that's how typically we draw the free body diagram. Now, the second force is going to be very important. It's going to be gravitational force. So the situation where it's asked is basically in all of them because all the objects that we're looking for have a mass. And the direction of application is always downwards because this is the force that the Earth is pushing on us with, right? So this is the force of gravity. So it's pointed to the center of the Earth, right? All objects experience gravitational force, therefore it's going to be applied in all situations. So you can safely always draw an arrow downwards and label it mg because that's the gravitational force. And by the way, this is one of the few forces that has a special formula to it, weight or gravitational force. Those are interchangeable words, by the way, is m times g. So m is the mass and g is the gravitational acceleration of negative 9.8 meters per second squared. Now, let's take a look at other types of forces. So, okay, if right now I'm experiencing a gravitational force that is pushing downwards on me, why am I not falling to the center of the Earth? Well, the reason is because I have this nice chair that is supporting me by providing a force upwards, right? So, but how do you call this force of the chair, right? Well, this would be any surface. So normal force is a force of the surface. So the situation where it applies is, of course, when an object is in contact with the surface and that surface prevents it from falling through, right? The direction, since it's related to the surface, the direction is going to be perpendicular to the surface of contact. So for example, if I have a box that is just sitting on the table, right? My normal force will be directed upwards, right? Again, at 90 degrees to the surface. And of course, here I also have the gravitational force, right? Pointed downwards. However, it's not always going to be exactly upwards. Like let's say if I have a box, on the other hand, on the inclined plane, right? Here, 90 degrees or perpendicular to the surface is going to be in this direction right here. So here the normal force is going to be pointed like this, and the gravitational force is going to be pointed still strictly downwards. Okay. The next force we should all keep in mind is the tension force. So tension force is really only going to be applied if there is a rope, string, or a cable, right? So if you have a problem where there is rope, string, or a cable, there will be a tension force. And because it's a force due to a rope or a string, it's always going to be pointed along the string, right? So let's say if there is an object that is hanging, right, the tension force is going to be pointed just upwards along the rope. And there's also going to be gravitational force, right, pointed strictly downwards. Let's say if you have some other situation, so where maybe this kind of object is tied like this by two strings that are at the angle. So in this case, again, the tension is always going to be pointed along the string. So this would be tension 1 and this would be tension 2. And of course, there's still gravitational force mg strictly downwards. Now, let's take a look at other types of forces. So we also have a force of spring, which we'll take a look later in more detail. So, but as you might imagine, the situation where it's applied is when you have a spring essentially that is being stretched or compressed, right? So just like the tension force is going to be pointed along the spring. So let's say if I put my object on a spring, right, my gravity is going to be downwards, but my spring force is going to be upwards, so along the spring. The spring force is going to be one of those formulas that does one of those forces that does have a formula. The formula is K delta X, where K is this spring constant, which you can basically understand as stiffness of the spring, right? So a car spring, for example, would have a really high K. A toy spring will have a really low K. But you don't need to memorize this because K will always be given in the problem. So they will say spring constant is this, right? Or maybe you would have to solve for it. And delta X is the compression or the amount of compression of the spring, right? Because the more you compress the spring, the higher is going to be the force, right? So it's going to be the distance from the equilibrium. Like let's say if here the spring is compressed, right? And here the spring is stretched to this point, the delta X is going to be by how much you compressed it by. But again, we'll take a look at spring force a lot later, so don't really worry about it that much for now. The one that will be important a lot is the friction force. So friction force is a force that arises when you rub one surface against another surface, right? So again, it acts between two surfaces in contact when there is a motion, right? We will talk in more detail in another video about two types of frictions, which is a static and kinetic friction. But for now, I just want you to know that the direction of friction is opposite to the direction of motion or to the direction of attempted motion. So let's say, for example, if I'm pushing my box to the right with some applied force, right, and it's moving to the right, my friction force is going to be to the left, right? If I have a box that's, let's say, is sliding down the incline, right, is sliding down the incline, then my friction force is going to be up the incline. On the other hand, if I was pushing it up the incline and it was going up, the friction will always be in the opposite direction of motion. So my friction would have been down if I was moving up, right? So those are just some of the examples. And similarly to friction force, we have air resistance force, which is not so common, but I would still like to mention it. It's present only specifically mention the problem. So in general, if something is flowing through the air, I don't want you to assume that there's air friction. Typically, they will just say ignore any air friction. However, in the few problems that we do have air friction, is just like regular friction, it'll be pointed in the opposite direction of motion. So let's say if gravity is pointed downwards, right, the air friction will be pointed upwards. If let's say, for example, if you're skydiving, right, and you're moving downwards, the air friction will be pointed in the opposite direction. One more thing I forgot to mention is that the friction force is one of the forces that has a formula, and the formula is mu times n, where mu is the coefficient of friction. So in other words, it's basically roughness of the surface, right? So for example, there will be more friction with or there will be less friction with ice than there will be with dirt ground, right? So ice will have a lower coefficient of friction, right? And n is the normal force, right? But by the way, this coefficient of friction is usually between, or not usually, it's always between 0 and 1. And air resistance force, well, it doesn't have one specific formula. If there is a formula, you'll be given that in the problem. So in this video, we basically looked over every single type of force. So this will be a really good foundation, really important for the next part, where we will learn a step-by-step instruction on how to approach Newton's second law types of problems and how to draw these free body diagrams and actually solve them. So keep practicing and keep watching these videos on your way to an A. Thank you.